In today's video, we're going to review the construction, design, and operation of this QRP-Guys multi-Z antenna tuner. Well, more accurately called an antenna transmatch, because it really is an adjustable impedance transformer to match an antenna to the output impedance of a transmitter. One of the things I like about this kit, and the reason I picked it up, is because it's really small. You can see from the main board and the front panel, when it's fully assembled, it literally would fit in the palm of your hand. Very easy to take out on the road if you're setting up a portable station out in the woods or a park or something like that. The design of the tuner, which we'll take a look at a little bit later, is based on kind of a Z-match design. There's a little bit of a modification to it. It also has a built-in SWR indicator, so you don't need to bring an SWR meter or have a rig that has an SWR meter to establish a good match. It comes complete with circuit boards, all of the parts, and a really nice 13 or 14 page assembly manual. I'll include a link to where you can find this tuner in the notes down below on the YouTube page here. So let's get started with the construction. The assembly manual is really well done and very well illustrated, especially when it comes down to the 3 or 4 items in the assembly which are a little bit unusual or require special attention. For example, there's no case on the unit. The construction of mounting the front panel to the circuit board is really just done by soldering boards together. So it goes through a special technique of how to do that and achieve really good right angles when you do that. There's a couple of toroids that have to be wound. The one that's got 3 windings on it with a center tap, and it could be a little tricky, so that's actually very well illustrated in here as well. And also there's some modifications that you need to make to the polyvaricon capacitors. All of these things are really well illustrated and described. So we'll go through some of the details of the construction, but not focus primarily on that. I really want to get it put together and show you how you use it. So let's get started. Now, the first part of the construction is to solder the front panel to the main circuit board. And this is done by just lining up the solder connections here with similar letters, like C to C, here and here. Now the problem is when you solder panels together like this at right angles, as the solder cools it tends to shrink, and that would tend to pull the panel out of alignment from its 90-degree desired position. So the manual describes that if you hold it up against a jig that gives you a 90-degree angle and stick about a 32nd of an inch piece of wire behind it, that'll create slightly more than a 90-degree angle. So when you go and bring the solder in here and solder this up, when the solder cools, the panel will straighten to 90 degrees. Okay, with everything held carefully in place, I'm going to bring the soldering iron in here and simply tack this together with a small bit of solder and let that cool. And we'll do the same for the other side and then solder the gussets in place. Okay, using that technique with the spacer, we're able to tack the front panel to the main board in 2 spots here and get a nice perfect 90-degree alignment of the front panel to the main circuit board. Now we can solder in the 2 90-degree gussets on the sides and then fill in the rest of the solder joints. And then we mount the tune and operate switch, 4 resistors, a capacitor, and a diode. So the next little bit of construction is to bend the legs for the LED to mount over this switch. And it says to bend them at a 7/16 of an inch. And the easiest way I found to do that is to take a calipers adjusted to 7/16 of an inch and use the inside measure to hook the LED on that, and then just bend the leads over the other edge, and you've got to bend right at the right dimension. Next, it's time to wrap one of the toroids, and you may remember one of my toroid winding videos where I use this little trick to use a sharpened chopstick. This toroid is going to have 25 turns with a tap at 5 turns. And after careful winding and counting and tinning of the leads, there's our finished toroid. Now with the tap toroid mounted to the board, we just have to secure it with a nylon screw, washer, and nut. Mounting the toroid is followed by mounting these 2 switches and the BNC connectors. Now the next step is to modify the plastic covers that cover the polyvaricon variable caps. And this is how they're received. We basically have to pull off the plastic cover here, deepen these notches by about 1/8 of an inch, and then put it back together, and then be able to then bend the leads down so they reach the circuit board when it goes in. The covers can come off by simply carefully kind of prying away at the two clips on either side of the cover, and they'll separate that from the capacitor itself. Then we'll simply use an X-Acto knife to deepen these notches by about 1/8 of an inch. And here's the difference between the two, one that's been modified and one that has not yet. And here are the caps reassembled with the deepened slots to make it easier to solder to the boards. The instructions do say that this lead here on the right edge is probably going to be a little too short to reach through the board anyway, but you'll be able to solder it to the top of the board, and that's not a problem. And next, those polyvaricons get mounted to the front panel with the two short screws, and then the leads get soldered down through the board. Now the last bit of the assembly is to wind this transformer. You can see that it's actually 3 separate windings, one of which has got a center tap, and it gets wound on this large toroid. And thankfully the instructions to wind this toroid are actually very clear with really well done illustrations and photographs. So we start by soldering a tap in the middle of a 30-inch long piece of wire that's going to be used to wind the primary. The life-size pictures in the assembly guide make it easy to ensure that you've wound the center tap primary correctly. And with careful counting and wire management, we wind up with the finished transformer with the center tap primary and 2 secondaries. All the wires down along this edge are coming off the bottom of the toroid, then you have the center tap, and the other 3 wires coming off the top. So it's easy to keep track of which wire belongs to which turn. Now with the transformer soldered down to the board, the last thing to do is secure it to the board with the PCB washer, and then put the rubber feet on the bottom, and we're done. Okay, with the tuner transmatch complete, let's go take a quick look at the design, and then we'll see how well it works. Well, let's ignore this part of the circuit here, because that's just the SWR indicator, and take a look at just the tune circuit. We can see it's a center tap primary transformer, a couple of tuning capacitors. This structure of tuner is often called a Z-match, and there's a lot of information up online about how well that works. And then there are 2 secondaries. The high-low impedance switch that is right here in the tuner selects between the 6-turn secondary or the 12-turn secondary. You can see that in this double pole double throw switch. And then the wire or coax switch right here, it determines whether or not we're going to ground one end of the transformer and drive a single-ended wire or coax, or if we're going to essentially drive a balanced line like a twin lead or ladder line. This part of the circuit here is the SWR indicator. When you're tuning up, you'd flip to the tune position, and that puts in this kind of bridge circuit. Now the easy way to see that this is a bridge, if we kind of cover up this portion of the circuit here, we see we apply a signal to the top of these 3 resistors, or these 2 resistors here. So it's a 51 ohm and 51 ohm resistor to ground, and then a 51 ohm resistor and essentially what would be our tune circuit. So if the tune circuit over here is adjusted so that the impedance looking in that direction is also 50 ohms, then this is essentially going to be 50 in series with 50 along with 50 in series with 50. So at the end of the day it's 100 ohms in a parallel with 100 ohms, so it looks just like a 50 ohm resistor. So the transmitter is going to see a perfect 50 ohm load when this circuit is tuned to give a 50 ohm input impedance. Also, when this is tuned to a 50 ohm input impedance, the voltages that appear here and here are going to be identical and in phase, because a 50 ohm resistive load appearing here would be just like having a 50 ohm resistor there. So these are identical circuits, so we'd have identical voltages appearing here. Therefore the voltage appearing across this part of this auto transformer would be 0, and therefore no voltage would be generated, rectified, and then cause current to flow through the LED. So the LED is off when we're tuned to a perfect 50 ohm load. If we're not tuned to create a 50 ohm input impedance here, there's going to be a voltage difference between this side of the bridge and this side of the bridge. That voltage difference is going to induce a larger voltage at the top of this auto transformer. That RF voltage is then going to be rectified and somewhat peak detected, if you will, onto this capacitor, creating a voltage that will appear across this resistor and LED, and the LED will light up. So you'll get an LED light up here when you're not tuned. So essentially you just key up in the tuned position, adjust the two capacitors until the LED goes out, and then you know you've reached a tuned condition. Okay, so here's an example of putting the tuner to use with my little FT817 5-watt rig here. I got the rig set to AM because that's going to transmit a carrier that's even well under 5 watts, just about a watt or two. So we use that for tuning up. So we'll start off by switching the tuner into the tune mode. That puts that tune bridge in place so that the rig will never see anything more than a 2-to-1 SWR, so perfectly safe for the transmitter. And then we'll just start adjusting some things here. I'll key up. We see the LED has come on SWR. So if we can get that to dim at all, looks like it dims ever so slightly if I've got the this tune capacitor there. And then we adjust the other capacitor here. And no real change. Let's go back and forth here. Sometimes you got to play with this a little bit. Oh, there we go. Look at that. Right about there. Very sensitive. We can see it's just going out right there. And if we adjust the other capacitor, let's see, it comes back on, and it comes back on. So we found that one sweet spot where the LED goes out, and that indicates that we've tuned the antenna system so that the transmitter is seeing 50 ohms. Once that happens, you switch over to operate. That takes that bridge out of circuit, and now you're ready to operate. Well, I hope you all enjoyed this video on the QRP-Guys Multi-Z 40m to 10m QRP low power tuner kit. Really easy kit to build, some nice quality components and circuit boards, goes together real nice, and a really handy little tuner to bring out into the field. Again, check down below for links of where you can get your own tuner like this. And thanks again as always for watching. If you liked the video, please give me a thumbs up. If you haven't subscribed to the channel already, please do so. And if you like it, share it with your ham radio buddies. See, they might like to see this tuner as well. Thanks again as always for watching.